Students, today I'm going to talk to you about Earth's resources. So there's so many resources on the Earth. This is just a few of them. You can see there's solar energy, soil, coal, birds, plants, oceans, energy, flowers, minerals, natural gas, the atmosphere, fossil fuels, oxygen, animals, metals, timber, all of these things are resources. And what that means is that they're necessary for us to live our daily lives. So, resources throughout the world are not all just concentrated in one place, and they're not evenly distributed either. They sort of come in like groups where some places you'll find a lot of something and less of something else. And so the Earth's natural resources are not evenly distributed, and they are scattered throughout the world. Some of the resources are renewable. The word renewable in this sense means that if you can replace that resource in your lifetime, in a human lifetime, then it is considered renewable. So this is kind of a little kid looking list of resources that are renewable. So I know it's kind of little kiddish, but it was a great list, like cattle, corn, deer, geothermal energy, hydropower, chickens, food, crops. Those are all renewable in the length of a human lifetime. They can be replaced. Even trees and wood can be grown fast with certain species. There's some species that are totally non-renewable. This one is petroleum, and we turn that into gasoline. And then this is natural gas, which you can use to heat your house or food. This is coal, and coal gets burned to generate electricity. And this is ore. I put a Minecraft ore because I know that's what you think ore looks like, but this is all ore. And ore is just simply something that can be mined for profit. These types of resources are not going to come back in a human lifetime, so they are considered non-renewable. Okay, resources. So we can't get them back. These ones, we have to be really careful about how we decide to use them. So when we use different resources, there can be pollutants made from the use of those resources. So I wanted to show you just how CO2, which is often talked about as a byproduct of using fossil fuels, I wanted to talk to you about how CO2, why it's such a touchy subject and bad for the environment in the quantity that we're putting it in. CO2 is actually a poison to us. It's actually poisonous to us. That's why we exhale it. That's why also, if you're kept in a locked place for a while, that you die. You actually will die from the CO2 poisoning. It's slightly acidic as well. So in order to even get it out of your body, your blood has to transfer it to a state of a bicarbonate, a base, to get it up to the lungs where it turns back into an acid and then it leaves your body. So CO2 is actually an acid too. And to keep your body safe, it actually transports it in your blood as a bicarbonate, so a base. It's kind of interesting. So when it goes out, here's the acid. Most of the carbon dioxide gets absorbed by our oceans. Our oceans are what's called a carbon sink. So a lot of things in the ocean will actually respirate using CO2, and it will actually bind to a lot of things in the ocean, but to an amount that's so high, and it's like almost overworking it, that now the ocean has increased in acidity. That increased acidity, some things can handle it, some things can't. Unfortunately, what dies first are the really little things. And when really little things die first, that's the bottom of the food chain, and everything above it ends up getting affected. So that's how CO2 negatively affects our oceans. We really, really need to be careful that way. CO2 can also affect our ozone. How does that happen? Well, it is an acid. And so when it rains, that accumulation of acid actually gets caught by the raindrops as it comes down, causing a an acid rain, which can actually erode things quite a bit. But additionally, CO2 actually dissolves what's called our ozone layer. Now, the sun, remember, is like a giant nuclear bomb in the sky. And the only thing that's protecting us from that radiation, from killing us, is, well, there's a few things protecting us, but the main protection is the ozone layer. The ozone is also extremely important because it keeps our earth at like a perfect temperature, and that's our atmosphere. Basically, that's why we have an atmosphere. And there's several other planets that do not have an atmosphere. So the ozone actually helps to trap some gases in. Well, CO2 actually eats ozone, and it actually dissolves it. And so more of that radiation can get in, more of that heat stays in, and it's pretty indisputable at this point that the Earth is experiencing heat changes and increases, albeit the numbers are very, very low. But even a small change in a giant system makes some differences. So it's something that we need to be careful about and just monitoring. So how can pollutants affect the air in our home? Lots of ways. There's all kinds of pollutants inside the home. Scientists estimate that the air is about 2.5 times cleaner outside of our home than inside of our home. So it'd be a lot better if we got out a lot, but we spend about 90% of our lives inside of a building. And here's just a list of all kinds of air pollutants that would be in a home in higher concentrations than they would be outside. Interestingly, about CO2, when a bunch of people are breathing out in your home, that CO2 gets trapped. So more of that poison is even trapped in your home. So open some windows, go outside, open some doors. It's good for you to try some of that fresh air sometimes. Okay, so water resources. So fresh water is so important for life. We have to have fresh water. We just do. But fresh water isn't everywhere. Now, in the United States and North America, so Canada as well, and Mexico, those 3 countries, we are water crazy users in North America. You can see by this blue line, we are using considerably more water than even Europe is. We are using so much more, like 50% more than what Europe is using, which is a ton of water. We just use so much water unnecessarily. When I go and visit other countries, it's crazy how little water I live on per day that I'm out doing field work when I'm in another country. I mean, it's literally a few gallons for bathing and drinking all day versus the United States. I use tons of water, and so it's just different how much we use. But we don't actually have that much water, fresh water, in the United States. If you look at this chart, there's a lot of, well, at least on the west coast of the United States. The east coast is doing quite a bit better. We're actually considered one of the most arid places in the world. So we're using too much, and we're kind of pulling it out of the ground and aquifers, and we're kind of overusing it. So we have to be really careful with that resource, which is why, people will always push you to be careful with how much fresh water you are using. Some places have actually mastered quite nicely. There's a lot of YouTube videos you can look up about how to desalinization plants and how they work. And what they do is they actually pump salt water through a filter, and they force it through that filter, and then they take that fresh water and they put new minerals in it to get it to try and to taste like the fresh water we're used to, and then it goes to a storage tank and then out to you. And I want to show you how reverse osmosis works. So Earlier in the year, you probably learned about osmosis, and osmosis is how water will actually by itself go through a filter, even upside down. It'll go through that to get from a place of low concentration to balance this higher concentration area over here. So even though there's more water here, this water will keep going through here just to balance it. And that's called osmosis. That happens all the time in your body, and it's an important process. So scientists came up with something called reverse osmosis, where they're trying to get the very salty stuff to come through a filter and catch the gross stuff and come out fresh on the other side. But that's not a natural process, so it has to happen unnaturally. So what they do is they put a high amount of pressure on that water to squeeze it through the filter, and then they take this brine and they take the brine, the really thick water that's almost pure salt, and they ship it back out to the ocean. So that's how they're doing reverse osmosis. Then there's this process called desertification. Desertification actually scares me because desertification is the process of one area being overused. It can be overmined. It can be have plants taken away or the deforestation. And what happens is that top few centimeters, which are good topsoil, gets lost, and it actually can change the weathered pattern of the area. So that area permanently becomes a desert. You can look up more information about this online. There's a number of areas in the world that did not used to be a desert that are major deserts now, that were overused earlier in Earth's history. And our area, scientists believe, is actually in the red zone of high probability that we're not just going to desertify, maybe. They think it's happening right now in Southern California. So we need to be really careful about what we take down and how we alter the ecosystem. So the loss of topsoil, the top few centimeters of soil, it takes about 1,000 years for rock to erode to give us give us 1 centimeter of topsoil. So topsoil is so important, and it takes thousands of years to get it back. Okay, in this picture, we're going to finish up talking about resources. I want you to look in this picture and see if you can spot some renewable resources. All right, so in this picture, I am seeing the sun. That's a renewable resource. I'm seeing hydrothermal energy. I am seeing some water energy coming down, and they're using this dam to get some energy. I see some wind energy. I see that these homes have solar panels. I see some other renewable energy like trees and things like that. So spot what you can in this picture, and think about Earth's resources as you go through this chapter. And when you're ready, take the test. Take care.